If they hold this course, they'll intersect the U-boats by dawn.
Signal the escort group to change vector point, Charlie.
The reading is unstable right here.
Check it again. We can't afford a weak point.
Helm, come right to 090. Steady on that course.
Aye, sir. 090. Steady.
January 1942. Dawn breaks over the sprawling Bethlehem Steel plant in Pennsylvania. Smokestacks pierce the gray sky, belching plumes of coal-fired steam into the frigid winter air. The clang of hammers echoes across the yard, mingling with the hiss of molten metal as workers in soot-stained coats move with urgent precision. Inside the massive forge halls, steel billets glow like molten rivers. Engineers hover over blueprints, tracing the curves of submarine hulls that the U.S. Navy desperately needs. Every second counts. Across the Atlantic, German U-boats are sinking supply ships faster than they can be replaced. The pressure is immense. The war is global, the stakes unforgiving, and America's submarine fleet hangs on the quality of steel these men can produce. Across the plant floor, a furnace operator wipes sweat from his brow, knowing that a single imperfection in the metal could mean a submarine failure miles beneath the ocean surface. Yet in this chaos, innovation sparks, new forging methods, radical heat treatments, and untested alloys. From the furnace's glow, hope for the U.S. Navy's submerged fleet begins to take shape. The battle for the Atlantic is fought not only at sea, but in the heart of American industry. By early 1942, the United States stood on the brink of a war that had already engulfed much of the globe. In Europe, Nazi Germany's U-boats prowled the Atlantic, slicing through convoys with lethal efficiency. Thousands of merchant vessels, carrying food, fuel, and armaments to Britain, were vanishing beneath torpedoed waves. Across the Pacific, Japanese submarines shadowed American fleets, probing vulnerabilities in naval defenses. For the U.S., the war was no longer a distant conflict. It demanded immediate industrial mobilization and strategic foresight. The Navy had long understood the submarine's potential. Silent, deadly, and capable of striking far from port, submarines could disrupt enemy supply lines and tip the balance of naval engagements. Yet, building these vessels required more than skilled shipwrights or tactical planning. It demanded materials capable of withstanding pressure thousands of feet below the ocean surface. Submarine-grade steel, dense and resilient, was a critical bottleneck. Traditional steel production methods could not supply the quantity or quality fast enough, and America's domestic output in 1942 was insufficient for the Navy's ambitious expansion. Bethlehem Steel, one of the largest industrial giants in the United States, found itself at the center of this crisis. The company had built its reputation on producing armor plate for battleships and artillery shells, but submarines presented a new challenge. The steel needed to endure the ocean's immense pressures without cracking, a demand that pushed metallurgy to its limits. Engineers pored over technical manuals, tested alloy compositions, and calculated the precise heat treatments required to achieve the perfect combination of strength and flexibility. Every kilogram of steel mattered. One flawed hull could doom an entire vessel and its crew. Meanwhile, the war's urgency transformed the industrial landscape. Factories that once produced civilian machinery shifted overnight to wartime output. Skilled workers were drafted into production lines, while women and older men filled the gaps in shipyards and steel plants. Bethlehem Steel's forges operated around the clock, coal-fed furnaces roaring day and night. The plant became a labyrinth of noise, heat, and motion, with molten steel flowing through channels like rivers of fire. Supervisors monitored gauges, adjusted temperatures, and coordinated with Navy liaisons to ensure specifications were met. Yet material scarcity compounded the challenge. High-grade nickel and molybdenum, essential for hardening steel, were limited. Imports had slowed due to enemy control of shipping lanes, and domestic reserves were stretched thin. Innovation was no longer optional. It was imperative. Engineers began experimenting with novel forging techniques, incremental rolling processes, controlled quenching, and precision tempering. Each test required meticulous measurement and documentation, as a single misstep could render a batch useless. The pressure to succeed was relentless, and the plant floor hummed with tension as the stakes of war pressed in. This industrial struggle was mirrored by the Navy's strategic calculations. Submarine deployment schedules depended entirely on production output. Commanders planned offensive patrols across the Atlantic and Pacific, calculating fuel, torpedo loads, and mission durations with the assumption that the next submarine would be ready on time. Every delay in steel production reverberated across naval operations, threatening to slow the counteroffensive against Axis supply lines. At Bethlehem Steel, the men and women on the line understood that their work was not just mechanical. It was a vital part of a global strategy. Amid this turmoil, a sense of urgency and possibility coexisted. Engineers sketched new molds and forging presses. Foremen inspected every billet for imperfections. Workers learned to read steel like a living material, listening for subtle shifts in sound, observing minute changes in glow. There was no room for error, yet creativity thrived in the pressure cooker environment. The stakes were clear. Success meant stronger, safer submarines capable of changing the course of the war. Failure could cost lives at sea and imperil Allied supply chains. As winter melted in the spring of 1942, Bethlehem Steel became a crucible of industrial ingenuity. The combined forces of necessity, expertise, and relentless effort set the stage for breakthroughs in forging technology. In the shadows of coal-fired furnaces and towering cranes, the future of the U.S. submarine fleet began to take form. Not in the open ocean, but in the glowing heart of America's steel mills. The story of Bethlehem Steel's reinvention is not just about metal. It is about the people, the technology, and the war that pressed them into action. At the heart of the plant, men and women labored under relentless pressure. Steelworkers, some barely in their 20s, moved with practiced precision around furnaces that glowed like molten suns. Sweat streamed down their faces. Cold dust clung to their clothes. Yet there was a quiet determination in every motion. One misstep, a flawed weld, a crack unnoticed, could compromise an entire submarine. For these workers, the abstract concept of victory was tangible in the weight of steel in their hands. Each plate rolled, each billet forged, was a direct contribution to the survival of sailors halfway across the world. Engineers faced an equally unforgiving challenge. The standard forging methods of the 1930s could not achieve the strength required for deep-sea operations. Metallurgists experimented with new alloy compositions, adding precise amounts of nickel and molybdenum to enhance resilience. Every adjustment required exacting calculations: temperature, rolling speed, quenching duration, and tempering methods. Laboratory tests were followed by trial sections, each scrutinized for flaws invisible to the naked eye. The tension was constant. Schedules demanded speed, but quality could not be compromised. In these moments, intellect met craft, and innovation emerged from necessity. The technological angle of this effort was equally remarkable. Traditional forging produced steel strong enough for surface ships, but brittle under deep-sea pressure. To overcome this, Bethlehem engineers devised a process of incremental rolling and controlled cooling, producing a more uniform crystalline structure. Specialized furnaces maintained precise heat levels, while hydraulic presses exerted unprecedented force. New non-destructive testing methods were applied. X-rays, ultrasonic inspection, and meticulous measurement of microstructural changes. The plant became a laboratory as much as a forge, bridging industrial might and scientific precision in a way previously unseen on American soil. From a military standpoint, the stakes could not have been higher. Each submarine delayed by steel shortages represented a gap in patrol coverage. Allied convoys were at risk, and the German U-boat threat loomed larger with every sunk supply ship. Naval strategists monitored production closely, calculating patrol routes and torpedo allocations around delivery schedules. The performance of a single hull in testing could determine deployment orders for months. In essence, Bethlehem Steel's innovations were as critical to the Atlantic theater as any battle fought at sea. The link between industry and frontline operations was immediate and undeniable. Leadership within Bethlehem Steel and the Navy played a decisive role. Company executives coordinated with military liaisons, balancing secrecy, production speed, and quality control. Decisions once made in boardrooms now dictated the fate of missions thousands of miles away. Foremen on the plant floor translated strategic directives into practical workflows, training new workers in accelerated programs, enforcing safety and precision under wartime pressure. Their leadership created a chain of accountability and creativity that allowed experimental forging methods to scale rapidly from laboratory to production. Even the enemy's capabilities framed the urgency. German and Japanese submarines, often constructed with advanced steel alloys, were already threatening Allied shipping lanes. Bethlehem Steel's innovations were measured against these standards. Could American submarines withstand deeper dives, longer patrols, and more torpedo launches without hull compromise? The comparison added a silent pressure, driving engineers and workers alike to push past conventional methods. Every successful forging test was a step closer to parity or superiority on the high seas. Finally, the moral and industrial stakes underscored the human element. America's entry into the war demanded more than courage at the front lines. It demanded courage in the factories, ingenuity under exhaustion, and persistence against material limitations. The plant's workers understood that failure could cost lives, not only of sailors, but of the countless civilians reliant on uninterrupted supply lines. Pride, duty, and the weight of national expectation combined to make Bethlehem Steel's forges a theater of moral as well as technical challenge. As winter turned to spring, the angles converged. Human effort, technological innovation, military necessity, leadership decisions, and global stakes formed a single narrative. Each perspective reinforced the others, showing how the reinvention of forging methods was not a solitary act, but a multifaceted struggle. The success of the operation depended equally on the hands guiding the steel, the minds calculating the alloys, and the eyes envisioning the submarines that would eventually slip silently beneath the Atlantic waves. In this crucible of pressure, innovation, and human endurance, the stage was set for a decisive turning point. The first successful production runs would test not only the steel, but the very system that had been built to deliver it. And in the shadows of the furnaces, the U.S. submarine fleet's future began to solidify. March 1942. Bethlehem Steel's massive forges roared with unprecedented intensity. The engineers had pushed their new forging methods to the limit. For weeks, billets of submarine steel had been rolled, tempered, and tested in a process that combined ingenuity with near-military precision. On this day, the first hull section intended for a fleet submarine was ready for its final inspection. In a cavernous hull, engineers and foremen circled the glowing steel. Each joint, each seam was examined under harsh light. Ultrasonic probes traced the internal structure, detecting hidden flaws invisible to the eye. X-ray plates revealed crystalline patterns, and each microfracture or inconsistency was a potential catastrophe. The tension was palpable. Failure would mean months of delay and jeopardize patrols across both the Atlantic and Pacific. Outside, Navy officers observed from the balcony, their crisp uniforms a stark contrast to the coal-smeared workers below. Captain William Macaulay, a seasoned submariner, leaned forward, scrutinizing the hull. "This steel will either hold the fleet together or let it down," he murmured, voice tight. No one responded. In the background, the rhythmic pounding of presses echoed like a war drum, counting down the seconds until the first test. The hydraulic press descended with a hiss, applying thousands of tons of pressure to the freshly forged plate. Engineers monitored gauges and thermal readouts, sweat streaming down their faces. The billet groaned under the strain, a metallic scream that was almost human. For a moment, the hull held its breath. Then, the plate held. No cracks, no deformities. Relief swept across the team, but there was no time to celebrate. More sections had to be forged, welded, and assembled before the first submarine could leave the shipyard. Weeks passed in a blur of molten steel and precision tests. Each success built confidence, but each failure was a reminder of the stakes. The first completed submarine hull, USS Gatto, was transported to the Norfolk Navy Yard under tight security. Engineers accompanied it, monitoring its structural integrity during transit. The shipyard's cranes lifted the massive sections into place, a choreographed sequence requiring exact timing. The hull segments aligned perfectly, a testament to Bethlehem Steel's revolutionary methods. By May 1942, the submarine was ready for initial sea trials. The vessel slipped quietly into the Atlantic, hull creaking under the weight of the ocean, as if testing the mettle of its creators. Engineers and Navy officials watched the gauges and hull stresses with rapt attention. Every dive, every maneuver was a test not just of the submarine, but of the steel, the process, and the human ingenuity behind it. The first patrols proved the success of the new forging methods. USS Gatto and her sister ships withstood depths that would have shattered earlier designs. Torpedo tests, emergency dives, and high-speed maneuvers revealed no structural weaknesses. The Navy's confidence soared. What had once seemed an insurmountable obstacle, America's lack of submarine-grade steel, had been overcome. This breakthrough rippled through the war effort. Submarines began deploying in greater numbers, silently patrolling the Atlantic and Pacific. Supply lines, once vulnerable to Axis attack, now faced an invisible threat from beneath the waves. The enemy had no inkling of the Industrial Revolution happening in Pennsylvania, yet it directly influenced the battlefield. Every successful patrol validated the engineers' calculations, the foreman's supervision, and the workers' tireless labor. In the Bethlehem Steel plant, the mood shifted from tense anticipation to cautious optimism. Workers who had spent months in near-constant motion allowed themselves brief glances of pride. The glow of the furnaces no longer only symbolized raw heat. It reflected the hard-earned triumph of ingenuity over scarcity. The Navy, for its part, recognized the plant as more than a supplier. It was a strategic partner, a silent contributor to victories fought thousands of miles away. By summer 1942, the first wave of newly forged submarines was operational. The U.S. could now challenge Axis submarines with vessels capable of longer, deeper, and more aggressive patrols. Bethlehem Steel's innovation had become a turning point, not in a single battle, but in the very capacity of the U.S. Navy to project power undersea. The victory was industrial, technical, and human all at once. The stage was set for the next phase, scaling production, deploying fleets in greater numbers, and confronting the global threats that loomed on every ocean. The story of the first successful steel forging was no longer just a factory tale. It had become a decisive element in the outcome of the war at sea. Summer 1942. The Atlantic was a war zone. German U-boats, prowled the shipping lanes, shadowing convoys and striking with lethal precision. But now, America's first submarines forged from Bethlehem Steel's innovative methods were ready to enter the fray. USS Gatto and her sister ships slipped silently into the early morning fog, hulls strong enough to withstand depths that had once been thought impossible. For the men aboard, the Atlantic was a crucible. Each dive tested not only their courage, but the integrity of the steel that carried them beneath the waves. Captain Macaulay commanded the Gatto on her maiden patrol. The submarine descended steadily, pressure rising, hull groaning faintly under the strain. Crew members monitored gauges with a mixture of tension and awe. For the first time, American submariners could push their vessels to operational depths with confidence. Months of industrial struggle, experimental forging, and sleepless nights by engineers and workers had converged in this single, high-stakes moment. Every creak of the steel, every vibration, was a testament to human ingenuity and endurance. Off the coast of Newfoundland, the Gatto encountered her first convoy. German freighters and escorts moved predictably, unaware that beneath the waves, a new threat waited. The submarine's torpedoes struck with deadly accuracy, sinking multiple vessels without revealing its position. Naval Command received reports of these successful strikes with cautious astonishment. Intelligence officers traced the performance back to the steel itself. Stronger hulls allowed deeper dives, extended patrols, and stealthier attacks. The once theoretical advantage of superior materials had become tangible, decisive, and immediate. At the Bethlehem Steel plant, the news of USS Gatto's success spread quickly. Engineers who had stayed in labs for months, and workers who had toiled in furnaces realized the global significance of their work. Telegraphs and phone calls brought updates from shipyards and Navy offices. The plant floor, once tense with fear of failure, now thrummed with pride. They had not just met the technical challenge. They had altered the strategic landscape of naval warfare. The Navy wasted no time. By late summer, additional submarines with steel forged through these new methods were dispatched to both Atlantic and Pacific theaters. Patrols extended farther, struck deeper, and returned with actionable intelligence. Axis forces began to note the growing efficiency and survivability of American submarines. Analysts later credited the introduction of these vessels with a measurable increase in the attrition of enemy supply lines. What had started as a crisis of materials at Bethlehem Steel had evolved into a turning point in maritime warfare. Behind the scenes, the coordination between industrial and military leadership became a model of wartime efficiency. Foremen ensured production lines kept pace with Navy demand, while engineers refined forging techniques to further enhance strength and reliability. Navy liaisons reported specifications, and Bethlehem Steel responded with precision and speed previously unseen. This industrial-military symbiosis allowed the U.S. to maintain a steady flow of advanced submarines, each benefiting from the lessons learned in earlier production runs. On the operational front, sailors began to develop confidence in their vessels. Submarine crews executed complex maneuvers that would have been too risky with older hulls. Emergency dives, prolonged submerged patrols, and rapid torpedo launches became routine. The reliability of Bethlehem Steel's innovations reduced fear of structural failure, allowing submariners to focus on tactics rather than survival. Morale soared, both on the ships and across the naval command. The Atlantic campaign was no longer one-sided. America had gained a decisive technological advantage. By autumn 1942, the scale of achievement became clear. The first wave of submarines had survived multiple patrols, sunk enemy ships, and returned to port intact. Bethlehem Steel's methods had moved from experimental to standard practice. Every successful mission reinforced the link between industrial innovation and battlefield success. The Navy's strategic options expanded. longer deployments, deeper patrol zones, and more aggressive engagement. The unseen battle in steel mills had translated into tangible victories in the open ocean. This turning point, where industrial ingenuity met operational necessity, redefined America's role in the submarine war. The success of the first steel-forged submarines marked a shift not just in material capability, but in the confidence and strategy of the U.S. Navy. What had begun as a desperate improvisation to overcome steel shortages had become a decisive advantage, changing the trajectory of naval warfare in the Atlantic and Pacific alike. As 1942 drew to a close, the stage was set for the aftermath: scale production, expanded fleets, and a reshaping of naval strategy. The work of Bethlehem Steel, combined with the courage of submarine crews, had irreversibly altered the balance of power beneath the waves. The story was no longer just about steel. It was about human ingenuity, industrial might, and the turning tide of war. By late 1942, the impact of Bethlehem Steel's innovation was unmistakable. The U.S. submarine fleet, once constrained by material shortages, now expanded rapidly. Submarines forged with the new steel were not only stronger, but more reliable, capable of deeper dives and extended patrols. Naval Command could plan missions with unprecedented confidence, knowing the vessels would survive pressures that had previously limited operational scope. Reports from returning submarines detailed long patrols, successful attacks on Axis shipping, and hulls that remained intact despite the ocean's relentless forces. Industrial consequences were equally profound. Bethlehem Steel had transformed its production lines into a finely tuned machine of innovation. Forges operated day and night, producing steel plates in quantities previously thought impossible. Engineers refined rolling, tempering, and quenching techniques, passing knowledge down the line to ensure consistency. Other steel manufacturers observed closely, adopting similar methods to meet the Navy's growing demand. The plant had become a center of both technical mastery and logistical efficiency, demonstrating the power of industrial ingenuity under wartime pressure. The human dimension of this achievement was striking. Workers who had labored for months in blistering heat and coal dust-suffused hulls now recognized the scale of their contribution. Letters from submariners describe hulls holding firm in emergency dives, and telegrams praised the durability and precision of the steel. Foremen and engineers shared quiet moments of pride, knowing that the sweat, fatigue, and careful calculations had tangible effects on the war effort. Morale on the home front, bolstered by stories of successful patrols, underscored the link between factory labor and battlefield success. Strategically, the Navy gained a tangible edge. Submarine patrols now targeted supply routes with a higher degree of risk tolerance, engaging enemy convoys more aggressively. Intelligence reports noted rising losses among Axis shipping, attributing part of the success to the depth and durability of U.S. submarines. Operational flexibility increased. Submarines could remain submerged longer, evade detection more effectively, and strike with precision. The first wave of steel-forged submarines had changed the calculus of naval engagement, providing both deterrent and offensive capability. The broader wartime implications were equally notable. The success of Bethlehem Steel's innovations demonstrated that industrial ingenuity could directly influence strategic outcomes. Materials scarcity, once a critical vulnerability, had been transformed into a catalyst for innovation. The Navy and industrial leadership established protocols for rapid problem-solving and technical adaptation, lessons that would shape production across multiple theaters of war. This industrial-military synergy became a model for future operations, illustrating how the home front could directly influence outcomes on distant battlefields. Yet the aftermath also revealed the human cost. Workers faced exhaustion, and the relentless pace of production took a physical toll. Engineers endured sleepless nights refining experimental methods, and every failure, Every cracked billet or flawed weld reminded all involved of the high stakes. Yet these hardships were balanced by the profound sense of purpose and contribution. Every successful hull, every submarine safely returning from patrol, validated the grueling labor and meticulous planning that had made such achievements possible. By the end of 1942, the U.S. submarine fleet was no longer constrained by material limitations. Bethlehem Steel's innovation had shifted from emergency solution to strategic advantage. Industrial mastery, human endurance, and technological creativity converged to create a fleet capable of shaping the course of the war. The narrative that began in glowing forges and meticulous labs had reached the oceans themselves, altering the balance of power beneath the waves. As 1943 approached, the Navy prepared to scale operations further, deploying more submarines, extending patrols, and striking deeper into enemy supply lines. The first breakthrough was complete, but the ripple effects, the accelerated production, improved tactics, and strengthened morale, were only beginning to transform the war effort. In the quiet of the steel mills and the roar of the Atlantic, the consequences of innovation were becoming undeniable, setting the stage for the final reflection on the significance of this pivotal chapter in wartime industry and naval history. As 1943 unfolded, the consequences of Bethlehem Steel's breakthroughs extended far beyond individual submarines. Production had scaled dramatically, with multiple plants now employing the innovative forging methods first developed in Pennsylvania. The U.S. Navy received hulls at a rate that once seemed impossible, and each new vessel reinforced a growing edge beneath the ocean surface. By mid-year, over a dozen submarines constructed with a new steel were operational, patrolling the Atlantic and Pacific with unprecedented resilience. Reports from the fleet highlighted the immediate impact. The USS Gatto, USS Gudgeon, and their sister ships completed extended patrols, engaging enemy convoys with both efficiency and stealth. Torpedo strikes became more audacious, patrol zones expanded, and American submarines began sinking tonnage at rates previously unattainable. Intelligence reports noted that Axis naval planners were forced to reconsider supply routes, convoy sizes, and escort deployments, revealing the indirect influence of American steel innovation on enemy strategy. Every successful mission traced back to Bethlehem Steel's ingenuity. The strength of the hulls allowed deeper dives, emergency maneuvers, and faster recoveries under fire. Industrial morale soared alongside naval success. Steelworkers, foremen, and engineers, some of whom had labored under near-impossible conditions, received recognition from both the Navy and the War Production Board. Letters and telegrams from sailors described hulls enduring extreme depths, while newspapers celebrated the home front contribution to victories at sea. In the plant halls, the rhythm of furnaces and presses carried both pride and urgency. Workers knew the war depended on continued output. The human story of resilience, endurance, and ingenuity became inseparable from the technical achievement itself. Strategically, the U.S. Navy's options expanded dramatically. Submarine commanders now had the confidence to extend patrols into previously risky regions. Supply routes that had been relatively secure for Axis forces suddenly became vulnerable. Allied convoys benefited indirectly, as U-boat threats were drawn off, diverted, or destroyed by more aggressive American submarine operations. The Navy's ability to project power underwater was no longer limited by steel shortages, but enabled by industrial innovation. Planners cited the quality of American-forged steel as a critical factor in operational success, linking production directly to battlefield outcomes. The psychological impact was equally significant. Sailors, foremen, and engineers shared a collective sense of purpose. Every billet, weld, and alloy adjustment contributed directly to lives saved and missions accomplished. Enemy perception shifted as well. Axis commanders, unaware of the industrial breakthroughs behind the hulls, faced a growing, invisible threat beneath the waves. Confidence in U.S. submarine operations grew, fostering boldness in tactics and cohesion among crews. The intertwining of human courage and industrial achievement created a force multiplier, amplifying both technological and operational effectiveness. Reports from the War Department and Navy highlighted numbers that made the achievement tangible. By the end of 1943, over 40 submarines were operational using the newly forged steel, with dozens more in various stages of production. Losses remained inevitable, but the success rate of hull integrity far exceeded previous standards. Operational readiness increased dramatically, and U.S. forces could now sustain continuous patrols in multiple theaters. Analysts later credited the steel innovation as a decisive factor in the eventual reduction of Axis shipping effectiveness, demonstrating that material ingenuity could shape the strategic outcome of a global conflict. In the plant, the culmination of effort was visible in every glowing billet and forged plate. Supervisors and engineers refined methods further, pushing production speeds higher without sacrificing quality. The workforce, hardened by months of relentless labor, had become both skilled and adaptive, capable of responding to technical challenges in real time. Bethlehem Steel had become more than a manufacturer. It was a strategic partner in war, a testament to the power of industrial innovation under pressure. By winter 1943, the full consequences were clear. Industrial, operational, and psychological forces had converged to reshape the U.S. Navy's undersea capabilities. Submarines were stronger, patrols were more effective, and crews more confident. The breakthrough in steel forging had transformed a potential vulnerability into a decisive advantage. What began as a material shortage had become a symbol of American ingenuity, endurance, and the interconnected power of technology and human effort. The stage was now set for reflection. The story of Bethlehem Steel, the Navy, and the submariners who benefited from their work illustrates how innovation under pressure can alter history. The lessons of resilience, creativity, and industrial determination would resonate far beyond the war, shaping not only naval strategy, but the future of American engineering. The story of Bethlehem Steel in 1942 to 1943 is a testament to the quiet battles fought far from the front lines. In the glow of furnaces, amid the roar of presses and the hiss of molten steel, American ingenuity met the urgency of war. What began as a crisis, a shortage of submarine-grade steel, became an opportunity to rethink, innovate, and overcome. Engineers, foremen, and workers transformed necessity into achievement, forging not just metal, but the foundation of a decisive naval advantage. Beneath the Atlantic and Pacific waves, the submarines carried more than torpedoes and crews. They carried the ingenuity, determination, and relentless effort of men and women thousands of miles away. Each dive, each patrol, each engagement reflected countless hours of experimentation, calculation, and skill. The steel that could have been a limitation instead became a strength, demonstrating the profound link between industrial capacity and military effectiveness. The broader lesson is one of resilience under pressure. Bethlehem Steel's experience illustrates how innovation often emerges from constraint, how human determination can turn scarcity into opportunity, and how technology and strategy are inseparable in shaping outcomes. The work of a single plant influenced the course of naval warfare, proving that wars are won not only on battlefields, but also in factories, laboratories, and planning rooms. Historically, the breakthrough reshaped submarine warfare. It enabled deeper, longer, and more effective patrols, directly contributing to the disruption of Axis supply lines. Strategically, it gave the U.S. Navy confidence, flexibility, and momentum at a critical stage of the war. Psychologically, It reinforced the connection between the home front and the front lines, between sweat-stained workers and sailors braving the ocean depths. Ultimately, the story is a human one as much as a technical one. It reminds us that ingenuity, courage, and collaboration, under the pressure of necessity, can turn the impossible into reality. The steel that emerged from Bethlehem's forges became more than metal. It became a symbol of America's ability to adapt, innovate, and endure, leaving a legacy that would influence both warfare and industry for generations to come.